Hi everyone, thanks for coming. So today I will talk about Kafka and Clojure and how they work together and what we use them for. So first of all, I work for Funding Circle in the UK, which is the biggest Clojure shop in the UK, even if it's not that big, but for Clojure is a lot of people. And we are using Clojure and Kafka as kind of the main pillars of the architecture. And I only joined recently, 3-4 months ago. So before I was doing Python and databases and other stuff for a long time. So I'm not claiming to be a Kafka expert, so forgive me if I won't know all the answers, but I'll do my best. So, so just to show what we're going to talk about, first I give an introduction to Kafka because how many people actually use Kafka for use it for work? Or okay, yeah, good, more than I thought. And Clojure, and the two together. Oh yeah, nice. Okay, so I guess I still have to kind of introduce Kafka a little bit and explain the main concepts and why it's good, and then just show how they work together. Kafka and Clojure, and show a little demo, and then discuss a more real-world scenario from our actual production code. In a way, I wanted to show more from the demo, but it turned out that it's quite difficult to actually show production code without having to show many thousands of lines of code which is not open source, and so yeah, the example will be quite simple, but hopefully will be nice enough to understand what's going on. So let's start with Kafka and what it is. It's a distributed append-only immutable log. What that means is that you have a kind of a central server which can be, however, distributed in a cluster on many different machines, and there is somewhere it represents a unique and immutable log which events get added one at a time in an append-only fashion. And the important thing about this is that it's extremely scalable because you always have a kind of a window where you look at things, and that means that you can you will always take the same amount of time to do a query in Kafka or to do some sort of operation. And that's why it was kind of, it's a very big project as well, mostly Java and Scala. And he also used Zookeeper for distribution, which is another kind of beast of a project. But generally you don't have to worry about that too much. You just fire it up and it does all the magic for you. And it was actually done for scalability because it was created internally by LinkedIn and then open sourced in 2011. So it's a relatively new project, but it just got to version 1.0 in the last, well, in September, October, I think. So it's actually now considered stable, even if a lot of very big companies were using it already before. By the way, if you have any questions while I'm going through things, we can do it more interactively as well. Okay. So the components of the Kafka cluster, in a way, are mostly four. You have a publisher API, a consumer API, a stream API, and a connector API. Publisher allows you to publish messages, events to a certain topic, where you say this thing happened, and you say it on this particular topic. Consumer, where you can actually consume the topics all at once, read as many as you want. And the more important ones, more interesting for us, in a way, are the streaming API and the connector API. So the streaming allows you to actually stream data from topics in real time and do nice computation with that. Like take some data from here, take some data from there, join it together, and do some computation and then output to another stream. And then the other important one is the connector API, which is a way to connect the Kafka to other sources of data, like any database really, both taking data from them or outputting data into them. So let's have a look at kind of an example of what a topic looks like and how from like the official, more or less official images I found. So here you have 3 partitions. Partition can be on different nodes in the cluster potentially, and a partition have the number here is the offset, and then someone can just write, like a producer can write on these different partitions on the particular offset at any time. And the important thing is that things never get deleted or changed, and that's quite an important property of the system itself. Then here is how, for example, consumers are look like. So you have consumer groups, consumer group A, consumer group B, and they are grouped together for various like technical reasons. And then each server has different partitions, and the partitions themselves will be eventually kind of redundant. So if a node goes down, then one node in the cluster that was the leader for the partition is not the leader anymore, and another one. And all that distribution stuff I think is mostly handled by Zookeeper. So each consumer can then listen to a specific topic which is on a given partition, and then get data and consume data from it. And last thing is that yes, you can consume and produce at the same time, of course, and multiple consumers can have different offsets. So the consumer remembers where it was left off reading, so then it doesn't read the same thing twice, for example. And lastly, this other nice graph represents what we actually do in a way, a funding circle, more or less. So you have data sources, and then use Kafka Connect to bring them into Kafka, and then you use Kafka Streams here to produce other topics, and then these topics are again written into some other databases. So the databases are then not the source of truth. So Kafka is always the source of truth in our case at least, and the databases are just used as kind of a temporary way to allow the actual different microservices to do all the nice things they want using proper language like SQL instead of trying to do other things. I mean, all the temporary things that doesn't need to be exposed to other project microservices can be in a database inside the service, and everything else that has to be common knowledge or anyone could possibly then has to be a Kafka topic somewhere. So that's a really short introduction about Kafka, and if you have any questions later, feel free to ask. But the Kafka was actually chosen, I think, a couple of years ago with Clojure as a way to try to scale to a very large number of customers eventually. And so the main reason was scalability, but it's not really the only one, because data integrity and auditing are also extremely important, since we are a FCA regulated business now. It also means that things that you cannot just go in like a normal business in the database and change things randomly and not actually have any trace of who changed what, for example. I've seen many companies that maybe for certain tables you implemented the audit log, and then for everything else no one knew. And the most funny thing was in one company where we discovered actually after I don't know 3 or 4 months that the audit log for some important table wasn't working anyway. So we didn't have audit log for changes on these kind of important tables for ages. And yeah, auditing and data integrity are both quite important things. And then the other thing is it kind of allows you to do microservices in a different way, I guess, and you can you don't have to worry anymore so much in how to share the data between the different services, because that's kind of a solved problem. You have other problems maybe, but at least you don't end up having all these APIs, which are then kind of never enough to get all the data, maybe too slow. You have all the data in one place, and then whoever needs the data from produced by different microservices can just subscribe to it, and depending on what they need. And I want to go through this funny graph from the Confluent guys, which kind of shows what the problem is. And you start from nice, neat microservices, and then you have these API on these services that are always too limiting for what you want, because maybe you want to have, you don't want to do 3 calls, but you want to get everything at once. And that's also why, by the way, things like GraphQL are quite successful. They try to tackle this part of the problem. And then if the services contract is too limiting, can we change both together at the same time easily? If you say yes, then I just make the contract a bit broader by changing the code somewhere. If it's a shared database, then, if it's a shared database, then it will cost a lot of money. And then you try to encapsulate again, especially when you actually scale. Scaling up vertically databases in RDS, for example, gets really, really expensive really quickly. If it's not a shared database, then probably, again, the service contract is too limiting, because no matter what you do, people normally just want to to do some specific queries that are normally, if you do them with an API, is always a pain. If you cannot change both services easily, then I just want all the data, and then you come up with some solutions to sync the data from one place to the other. I don't know, you can use even things like Elasticsearch, or you can do all sorts of stuff to try to get a live copy of the database on the other side. And if you actually try to, the data will diverge at some point, because of course you cannot have, like for the physical laws, you cannot have the same data in 2 places and expect it to be consistent. And then, okay, let's centralize everything again, and then you end up again in the same problem. So it's kind of it's an issue with data-centric companies, that even though you want to try to scale up, so have multiple microservices and so on and so forth, then you end up having really a lot of headaches with trying to actually get your job done. So that's why also, that's one of the reasons why Kafka guys really push for it. And let's look at Clojure now. I'm not going to give like a full introduction to Clojure, because it would take too long, and I expect most people have seen it already at least. But just some of the points that are important to also understand why it can be a good fit for working with Kafka. So first of all, it's a functional Lisp, and by functional it can mean many things, but it has, for example, all the various map, filter, reduce, all these nice little functions. And Kafka, in a way, Kafka Streams API in particular is very similar in this very. He also has map values, map like filter, all these different ways. And then by default, everything is immutable in Clojure, which is quite important. By default, I say by default because you can do mutable things if you want. But normally you only really do them for really specific performance reasons or similar things. Like 90 or maybe 95% of the times you never need to worry about I should maybe modify this vector in place instead of creating a new one, because you really most of the time you never have this issue. And in a way, Kafka is also immutable because it's just like an immutable log. So that's why they are kind of related. And data-centric is also very important. I think everyone heard about the data is code mantra in Clojure. It just means that you can, since the language is homoiconic, data is code and code is data. So the two things are kind of interchangeable in a way. And The other thing that is quite important for the community and for the language ecosystem in general is that data is superior to functions, and functions are better than macros. So whenever you can, you should try to keep kind of things in maps and vectors and similar data structures, which are easily manipulated by all sorts of tools. And then if you cannot do that, then just write a function. If you really instead the function is not enough again, then write the macro. Again, yeah, that works really well with Kafka. That is kind of simply like a data collection in a way. And then even more importantly, is based on the JVM, so it runs natively on the JVM. There is also Clojure script and CLR, for example, but the JVM interoperability is really nice to use. It can get a bit annoying if you really have to do it all for every call, but for that you just need some little wrappers, and then you don't even notice anymore you're working with Java libraries, for example, because this means that we can actually call the internal Kafka stream functions in Kafka libraries directly without having to I know people use them also, for example, Funding Circle use them with Ruby or Python, and it works, but yeah, it's not nearly as fun apparently. And the other thing is that this is very the REPL experience is great. I mean, I think it's the language I've used, well, apart from maybe other Lisp, but it's the language every time you can reload everything all the time. You can inspect what's going on. You can see the output of function directly in your code, as I will show you in a minute. And so yeah. So the conclusion of all this, I think we can say maybe that Clojure and Kafka are isomorphic, as this morning said Philip Bader said. So yeah, not really, but it could be. So now let's have a look at some real code. So forgive me for the simplicity of the actual example, but I just have to show something that I could explain from top to bottom easily. I don't know how is the theme coming up. Yeah, maybe. Is it big enough? Yeah, I'll do one more. Okay, so this example, all it does really is that it looks up in a topic called words, which is here, and it counts all the words. And well, it counts all the characters in the words, and then it outputs that in another topic, another count. So first we have here the declaration of the namespace, where there are some requires just for the logging and the environment library. And then here, this is an important piece of interoperability, where the import actually imports Java classes and not Clojure classes. And that means from this namespace import these two classes, for example. And then this gen class is just to get the execute to get the Uber Java. Well, it's not important in this case. Then after that, here there's a map to know which is the input and the output topic. And now another map which declares the configuration for this Kafka class that we are using locally. So there is an application ID, just a name, and then the bootstrap server config is the port and the host where the Kafka broker will be listening on, which is just the kind of the default one. And then here the serve the class config, value serve the class config is something, I'm not going to go into much detail, but is how you declare that the messages are serialized and deserialized, which in this case is just a string. In a way, if I wanted to show something a bit more complicated, like we have in our case, for example, it would be quite hard because even the JSON serialize and deserialize is not part of this library, so you have to kind of write it yourself, and we have it part of our code. So that's why also I have to show some quite simple example. So now the actual function that does the counting is just this word count, and the interesting thing is here that is simply a pure function, well, apart from the logging, maybe, if you want to call that a pure. But if I just pass something here, it simply returns the number of characters in the word. So that's all it does. Now I will define a builder. Now the builder is the thing that actually constructs the stream, K-stream builder, as a kind of global constant in a way. And then here is the important thing, is where you actually define the topology in this case. So the topology, you first take this, you call the, so actually before I do that, this syntax, method, object, argument. This syntax is part of the Java interoperability things, and what it does is that it transforms to, in the equivalent in Java would be object, method, and then other arguments. And yeah, so this is kind of a special syntax, and if I take this and expand it, then it will expand to dot, object, method, or other argument, where dot is a special form. So anyway, just this to say that this is part of the Java interoperability. And working with Kafka Streams and with Kafka in general libraries, you have to do quite a lot of these things. But at the same time, for actual real-life projects, there are a million libraries to encapsulate all this in Clojure and just show you a nice Clojure interface. So we're just showing you the bare like row thing you can do, but it's not how we do it actually, because it will be quite a pain. So anyway, create a stream, and then you pass the stream an array which contains the name of the input topic, and then here is you map on the values, because in this stream it can be formed of keys and values, where the key we don't really care about in this case, and the value are just a different word. And then here we have to do this kind of reification thing, which is again part of the Java interoperability. So to make this function satisfy the Valuemapper interface, basically that's what it means. And the Valuemapper interface expects that you take two arguments, the key and the value. We don't care about the key, and then we just wait, what have I done? And then we just return the word count on V. And then finally, the result of this thing will be written out to another topic, which is with this .to method. Any questions so far? Yes. Yep. Yeah, you. Yeah. I will show you now in. Yeah. Yeah, we're showing the code first, and then show how it runs. But yeah. Anyone else? No? Okay. Alright. So then we have a configuration here, and then the streams is what actually controls how the streams run. And now the main function simply start the streams, and then it stops after like a while. So I show you now how this runs, and I go to the terminal. So I'm not sure if you can read, maybe it's not big enough. So at the moment we have three terminals that are already busy in a way, which is one is the Zookeeper cluster. Well, the other one is the Kafka cluster, and the other one is the actual word count. I just killed the word count. I think, I mean, to actually run, I can show you how to run the Kafka cluster itself, but it's not very interesting. It's just one command from the Confluent thing. It's just being Kafka start. and for the zookeeper it's the same. And what we actually do for our development in general is that we use just Docker Compose, so then they are all done in a simple way, and there is a Docker Compose file in this repository as well, which you can have a look at. So now so there are two topics I was saying. So the interesting thing now is to first, I can look at the topics with this command, Kafka cat. I can kind of consume and produce things on topics directly, like this, the word. And here it tells me that there are two elements, which is hello world, already in the topic. And if I do the same for word count, because I ran it already before, well, it tells me there are also two elements here, and this 5 and 5, which is the length of these two words. So if now I actually add some more things to the words topic, and I kill it. Now I check again if they're there. Yes, so I add the two things. And now I consume instead word count, and I start the actual Kafka stream. It will output a lot of information. Yeah, okay, yeah, works. So what it did is that it went through the things it didn't see already, and because it knew where to stop, and then it will here is all the information about the configuration and all that kind of stuff, and then he simply output here 5 and 10 into the topic. Any other questions about this example? Very trivial. No? Okay. Okay, so if we go back to the actual presentation, this is another thing which is actually what I originally wanted to show, but then I realized it was way too complicated to show without sharing all the code. And this is what, for example, we do in our team, which is reconciling repayment and bank transactions, mostly. I mean, it's not the only thing we do, but it's part of the pipeline in a way. So suppose you have some payments and transactions that come from different sources. Actually, here I didn't do the graph correctly. So one come from one topic and the other one comes from another topic, and then you want to know if these things reconcile. So they are, and to reconcile they have to be the same amount, and the date have to be kind of compatible in the right way, and then some other rules potentially, but these are the two simplest ones. And then when they reconcile, then you output here on the left into the reconcile repayments. So you put them together and then you output them. When they don't reconcile, you output the repayments and the transactions separately as unreconciled. So that's how kind of a simple pipeline would look. You have 2 input topics, and then you have 3 output topics for the actual result. If I think about implementing this in Kafka and Kafka Streams, what you could do is that first you ingest the repayment topic, you ingest the transaction topic by subscribing on the topic with a string, and then you join them together, and then you augment this join records with some information about if you're reconciled or not. So basically just adding a field. And then once you've done that, you can branch on that and to the various topics. I will show you now the actual. I will not show you all the code because it's a bit too much, but I'll show you the actual data flow, how the data would look like in all these intermediate steps, just to be a bit more clear. So suppose you have a bank transaction topic here and the repayment topic here, where you have just 2 bank transactions and 1 repayment. So the ID is just the identifier, which would be a UID in our case, but it's just a number here. And then you have the amount and the value date. And the repayments, you have just one repayment, and with the effective date, which is kind of a similar thing but just different name. So this you can consider this the beginning of your pipeline. So from here, you first join everything together and compute if they reconcile or not. So by joining them, I just put transaction in a sub map in a way, and the repayment here, and then I call a function on this pure map that tells me if these two things reconcile or not, and I add the field here. And so for the first one, I transaction 1, repayment 1, reconcile, yes, and the second case they don't, so here is false. So once I've done that, I can actually branch, and then the output would be that ID1, so it should have been bank transaction ID1 and repayment ID1, and this one reconciles, and then this one goes to the repayments unreconciled thing instead, because it didn't. So and then the very important thing in this whole scenario is that what is actually the business logic. If you have a bit of wrappers around the Kafka internals and all that, the actual business logic is just pure functions that all they do is that they take some maps, they do some checks, they do some computation, and then they return some other maps, for example. And that's like 90% of the code will be like this. All the rest will just be a bit of wrapping around and the orchestration, but that's it. So if I have this reconcile function, which is kind of a convention in a Clojure to have a question mark for things that return booleans, for example, and then I pass here this map and then this other map, and then it returns me true. And here, all it needs, in a way, is that the map that contains the bank transaction has these two fields, and the other one has these two other fields, and that's it. So it doesn't need anything else. And the other interesting thing is that, of course, then you can also use Clojure spec and some other things for actual production. In the actual production thing, every topic has its own Avro schema definition, which then ensures that you have a schema that you know what data you have. But for example, we are also starting to generate Avro schema from Clojure spec definitions. So you can use the spec, and then you can validate your data that way. And then the spec also generates the Avro schema, which is then used in production to make sure things don't fall apart. So yeah, also these examples are part of that project if you want to have a look. But I can also just show you quickly that if I go to a core CLJ here somewhere, and this is the reconcile function, well, yeah, so this is the, you run some tests already automatically because, and now if I run reconciles and then I pass something, effective date. And then I pass a repayment here. Okay, yeah. So just to show that works, and to show how you can kind of evaluate things live in the REPL and even see the output there directly, or if you want to just go to an actual REPL, you can do it here. So yeah, the last thing is that this is just instead how you would do this augmenting. You just take the repayment and the transaction, and then you put them together like this. You kind of prefix them with the bank transaction and repayment, and then you augment it with the information from this pure function. And that's all I had to say for today. And conclude. I think it was hard at the beginning from what I heard, like stories, but in the end, I think everyone now is quite fond of, definitely fond of Clojure. Clojure, it works now really well with Kafka, and we kind of have quite a lot of fun with that. And for the transitive property of love, we also love Kafka. And last thing is that I want to mention is that we're also hiring, so if you are interested in working in London, there is an office also in Amsterdam and Berlin, talk to me or just contact the website. That's it. Thank you very much.
Thank you, Andrea. So we have about 10 minutes, which is enough time for five questions, I think. Okay, so up there. Could you just put your hands up again?
Okay, thanks for the great presentation. Well, I was wondering about how Kafka, in Kafka, how do you deal with things like disaster recovery? You have mentioned that Kafka is your only source of truth, and you probably have more databases that you need to recreate from that state. Is it really working? I mean, is it really possible to create those databases in a reasonable time out from Kafka? To recreate those databases?
Yeah, so good question. If it's possible to recreate databases in reasonable time, I think when it happened that the database, like recently, there was simply a bug that deleted like a table, or someone manually deleted a table by mistake, and what they did is just well, that was an old app. But what it did is just replace it from the logs, from the backups in that case. But in a way, I don't think it ever really happened that there was like an entire database that had to be recreated. In theory, it's not so simple, because like databases that I was mentioned before are in a way, or some tables will be taken directly from Kafka Streams. So they just kind of, you take the stream and then you dump it to a database table. And that part is quite fast. I mean, we don't have, in most of the tables, we don't have many records, less than millions. It's not too much. But the process itself is really fast. The Kafka Connect jobs are fast. But the thing is that the same database for the microservice will be used for many other internal things, which are not stored in Kafka anywhere. So I mean, you would still like do recovery like you normally would do anyway. And then the next time that Kafka Connect runs, it will update the things that are now wrong. For example, what it actually does is that it observes on IDs that are already there. So it will simply override things. So I think for me the answer, if I understood correctly, is just that you handle that for microservices related database in the normal way that you would do. So you just take the backup and you restore it, and then the part that Kafka is concerned with will just automatically work because of how jobs are working. As question there?
How do you version Kafka topics? And second question, how do you find the transactions with the same ID? In your example, you found 2 transactions with ID 1. So how did you do that?
Yeah, good question. Well, the versioning is it's kind of a problem that is solved by using the arrow schemas, which allows you to actually have allows you to actually define new fields, and every time you add a new field, however, the only problem is that you have to make it not nullable, because otherwise, not nullable, sorry, because otherwise all the old messages are, if you do have a breaking change to a topic, we do that as well, then we simply bump the name to like in the next version, and then there is something called like a schema registry, which kind of keeps track of all which is still part of Confluent, the same thing, which keeps track of all the latest production topics, and then you simply use, for example, like a repayment 3, and that's kind of the latest one. But if another project is still using repayment 2, if that doesn't break, it doesn't break. Everything still works, but maybe the new data will only be added to repayment 3. So it depends. It really depends on the case in a way. So if, for example, it's a topic that no one is using yet or something like that, then you're still versioning, but you don't have to worry about migrating data. You don't have to worry. If it's something that is already in production, then you behave differently. So, but there are some kind of good ways to handle deal with that. And that's the second question. The idea, I mean, this is just made up things. These are not real. This is not real data. Just so yeah. Yep.
Yeah. So long story short, you work for some kind of financial institution. At least some money were involved in the code, which means that a lot of compliance, questions and stuff like that. By default, Kafka is not multi-tenant. So if I have physical connectivity to the host, I can listen to whatever I want, which means that in your case I can create some kind of consumer which grabs someone's financial data and screws somebody really hard. So the question is, how do you work around that? How do you make it pass all of these boring banking compliance issues? Because in Postgres you cannot just do that for 15 years, or already in Kafka, as far as I know, you cannot do that so far natively. So how do you work around it?
Very good question. I think, I'm not sure I heard everything, but it's about, if I understood, how to deal with kind of data that is sensitive and you don't want everyone to read and that kind of stuff. So the solution that is used in Funny Circle, I think, but it's probably not the only place, is to use Vault or Vault, the HashiCorp project, to actually store all the PI data. So that means that whenever something writes into Kafka, if there is some data that shouldn't be written to Kafka because not everyone has access to it, it will be written to Vault and hashed, and the hash stored into Kafka to be able to reference it. So that means that that's important for two reasons. First, the reason you mentioned, that you don't want everyone to read everything. That would be quite bad. And also because in Kafka we can never delete anything. So that means that if we write something there, we are kind of stuck, and so it's quite a problem. And with this solution, well, it means that if there are some application like a CRM that actually needs this data, they can still get it, but everything will be kind of tracked and taken care by the Vault, which handles all the permissions and stuff like that. So. One here.
Hi. Can I use Kafka as a durable queue? Like, for example, if my consumer read some message and failed at processing, how can I signal that it's need to retry? Like, what strategy can I use for that?
If your if your consumer fails and then doesn't send the message, I think you don't need to worry about that too much in a way, because, well, I mean, we normally worry about the opposite, that you don't send the multiple messages more than once, not the same message more than once. And the drivers themselves, I think, are handling all the retries in case there are problems there with actually sending the message out. I mean, if Kafka goes down for a while, then it's a big issue in a way, and I'm not sure. I'm not sure if things would be automatically happening, or I'm quite sure there is an internal queue inside the libraries themselves that you use to do stuff, so you don't have to do that yourself. Like the talk that the other guy did this morning here, I don't know who saw that, but he mentioned exactly that. They added some retry mechanism, and then the discovery was doing it twice because there was already a retry inside inside the library. So.
Yeah, I mean, for example, if my consumer goes down, but before it goes down, it actually took a message from a queue, so I can lose message, right?
Before it goes down, I see. Yeah, well, that's that's more. I'm not sure. I mean, in theory, you can always manually go back in the offset when you need to, and that's what they did a few times when there was something similar. But I don't think it's something that really, especially, I mean, if you are using also things like Kafka Connect to actually dump to database that then you use, this really, it's never really a problem in a way, because when something is there, it's already durable in your service as well. And
okay,
so,
thank you.
yeah, it depends on, I suppose. But.
Shall we break for coffee? Sorry if you didn't make a question, but you can approach Andrea outside, I suppose. Please remember also to vote if there's someone outside with an iPad. Let's give Andrea one more show of appreciation.